Okay, in this lesson we're looking at what's known as simultaneous equations. So simultaneous equations are just simply if you've got two equations, and because we're looking at linear, so say for example we've got two equations that end up being a couple of straight lines like so, then the simultaneous equations, or the solution to the simultaneous equation, tells us the point of intersection. So the solution is the point of intersection. Of the lines. All right, so when we're talking about solving simultaneous equations, what we're talking about is finding out algebraically, is how we're going to do it, where they intersect. All right, so we're doing this by hand, even though calculator, it is possible to do it on a calculator. We're doing it by hand because the Year 12 syllabus for maths methods says that you can be expected to do two unknowns algebraically. So let's have a look at some examples. Now you have done this before, so you might get something like this, solve simultaneously. And so here we've got 2x minus y equals 4, and x plus 2y equals negative 3. All right, so there's a couple of different methods that you can use to solve simultaneous equations. When they're in this form here, so you'll notice here we've got the x and y on one side, and then on the other side we've just got the number. So when we solve these, what we're going to do is use what's called elimination. So elimination, and so for elimination, as it suggests, we wouldn't want to eliminate one of the variables, so either x or y. All right, so let's have a look at how we would do that. Now, the way that I like to set it out is that I will go 2x minus y equals 4 on the top, and underneath it I will go x plus 2y equals negative 3. All right, so to eliminate, we need to get the coefficient in front of the x or the coefficient in front of the y. We need to get it the same size. Not too worried about the sign, whether it's positive or negative, but at least it needs to be the same size. So we either need to change the second one so that we can get the 2 in front of the x, or alternatively to change the first one to getting 2 in front of the y. Now which one you do, it makes absolutely no difference whatsoever which one you do. So what I'm going to do, I'm going to change the x so that I get a 2x in front. So 2x in front, so I need to times by 2. So I'm timesing everything by 2. And so when I do that, so I'll write the first one, the top one, 2x minus y equals 4. So when I times everything by 2 there, I end up with 2x, 2 2's are 4 plus 4y, and 2 times negative 3 is negative 6. All right, so now we're going to eliminate, and in this case we're eliminating the x. So we've got 2x and 2x, so to eliminate we need to take away. So we'll do 2x minus 2x is 0, lots of x. Then we've got minus y minus 4y, so that would be minus 5y. Then we've got 4 minus negative 6. The minus negative is plus, so 4 plus 6 is 10. And then when we divide by negative 5 both sides, then I'll squeeze it down here, y equals negative 2. Alright, so now we need to find what x is. So we know the y value, so to find the x value we stick it into any one of these equations. And the one I'm going to use is x plus 2y equals negative 6, I think. No, negative 3, now I've got that right. And y, of course, was equal to negative 2. So I'll substitute that in there. X plus 2 times negative 2 equals negative 3. X minus 4 equals negative 3. Add 4 to both sides. And x is equal to 1. So the solution is 1 and negative 2. So what that means is that those two lines, if you draw them on a graph, that's where they're going to intersect. All right. Okay, so this next one. So solve the simultaneous equation. So I've got two equations, y equals negative 3x plus 6 and 5x plus 3y equals negative 2. All right, so this time what we're going to use is, you'll notice that the equations are in different forms here. So this time we've got y equals something. So whenever you've got, say, y equals or even x equals, what we can use is what's known as substitution. So what that means is I'm going to substitute, because y is the same as negative 3x plus 6, I'm going to substitute that negative 3x plus 6 in here for y. So when I do that, I get 5x, that stays the same, plus 3 lots of what? 3 lots of negative 3x plus 6, because that's what y was, and that's still equal minus 2. Expand, collect my like terms. So I've got 5x plus, no, minus, because plus 3 times minus 3 is minus 9x, plus 18 equals negative 2. Put those together and take 18 from both sides. So 5x minus 9x is minus 4x equals minus 20. Divided by negative 4. And x then would be 5. So now we take that x and we substitute it in, and I'm going to substitute it in the y equals minus 3x plus 6, and we found out that x was 5. So y then is negative 3 times 5 plus 6, negative 15 plus 6 would be negative 9. So these two lines, intersect at 5 and negative 9, if we were to draw them on a graph. So they're the two methods that you can use to do algebraically. Now, there's certain, let's call it the geometry of simultaneous equations. So, in other words, what does it mean? Well, there's three possibilities. Of things that you could get. So, the first possibility, say things like this, 2x plus y equals 5, and x minus y equals 4. Now, if you solve them, you get a unique solution. So what does that mean? The word unique, don't get thrown by it. All it means is that you get an answer, and you get one answer in this particular case. And the unique solution for this is 3 and -1. So what does that mean? What that means is that we have two lines intersect at a point. All right, so two lines and they intersect at a point. All right, so that's the first possibility. So you get an answer. Second possibility is say something like this: 2x plus y equals 5, and 2x plus y equals 7. Now, when you have a look, and you'll notice that the left-hand side is the same, but the right-hand side is different. So if you tried to solve this, you'd have no solution. All right. Yeah, spell that kind of right. So, for example, if you tried to take them away, for example, you go 2x minus 2x and you've got no x's, and you've got y minus y, so you've got no y's, and you've got 5 minus 7, which is minus 2. So if you've got no x's and no y's, you've got 0, and 0 equals -2, which we know does. So in that case, we've got no solution. So what does that mean? Well, what that means is that we've got two parallel lines, like that. All right, so quite clearly parallel lines, they don't intersect. All right, so no solution, that makes sense. Now the third case, case number 3, is something like this: 2x plus y equals 5, and 4x plus 2y is equal to 10. Now, this one's a bit strange because we have infinitely many solutions. So you're kind of thinking, what's he on about? How does that work? Well, if we look at this one here, you'll notice 4x plus 2y, there's a common factor of 2 there. Then we've got 2x plus y equals 10. So 10, of course, is 2 times 5. So we could divide by 2 both sides, and the 2's cancel, and we get 2x plus y is equal to 5. So infinite many solutions, as you can see there, once I've done that cancelling out, I end up with the same equation. So infinite many solutions, what that means is that we've got two versions of the same line. So we've got one line like this, and then the other line right over the top of it, like that. All right. So some practice with these. All right, we'll get more into what it actually means a little bit later, but as we get through into the course, as I said, you need to be able to do two simultaneous equations, two variables by hand. So we're doing these by hand. So this is on your work plan, the exercise 1C questions.